CLion a cross-platform IDE for C and C++. Download now.
Error handling omitted. Anyone ever seen that phrase? Yep. Anyone as annoyed by it as I am? Yep. So I'm going to have a brief look. A brief look at what's left out when we omit error handling. And it's partially based on my own experience of seeing example code in blogs, books, documentation. Documentation often tells you how to do the thing, but not what you do when the thing doesn't work. Or it kind of hints at a solution, but doesn't give you enough information. How do we learn things in this business very often? By example, from trying them, yep. AI, yeah, AI. A lot of it's based on the things we see shown in the code that we've read or the code that we're modifying. And so when we have bad examples in documentation and code examples, we copy the bad examples because we don't know how to do it better. So an example from Koenig and Ritchie. Who's read the C programming language? Yeah, you're among friends, right? A disclaimer. We are generally not worried about exit status in our small illustrative programs, but any serious program should take care to return sensible, useful status values. Could I have some examples of what's a sensible, useful status value? The book doesn't really provide any. So it kind of says, this is what you should do, but doesn't give you any idea about how you do it. I mean, I'm not knocking it, it's a brilliant book, but it just doesn't really cover that side of programming. Or a more recent version. Oh, something's odd happened there, never mind. The Windows API call, close handle, shows this example. It checks the error return from open process and does something. It checks the error return from get priority class. And the function is actually illustrating close handle has no error handling at all. It just ignores the fact that it's a Boolean function. And this is the example code for that function. Now, admittedly, I'm not quite sure what you would do if close handle returns false. But that's the thing I'd like to look in the documentation for. Should I be handling a false return from close handle? How does the example code do it? It doesn't. So back off by one. Why is error handling omitted? And I was sort of thinking about this and looking at a couple of things on the web. And I think there's several reasons. And I'm sure you can think of some reasons. Who can think of good reasons why error handling is often omitted from examples? Any thoughts?
How's that? Oh, excellent.
We're getting some feedback, aren't we?
Yeah, I've had some students asking about how we should be using LLM.
We seem to have a problem.
And I think some adults need to know as well. And I find it very useful for certain things. For example, how
do we know what the problem is? It's just coming through the wall. Is that all? Okay.
Yes.
No, it's actually
do this
on that speaker. You seem to have a speaker that's picking up from the next room.
Because I've been put onto the works version of GitHub Code.
Or maybe not. Error handling, yeah, it's been omitted.
Which is why I've got to ask you what the hell context for is, because people keep talking
1 minute, yeah.
No.
We'll carry on with the questions. Why do you think error handling might be omitted? You had a simplicity of examples. Who thinks that's a good reason for omitting error handling? Sometimes. It's a good reason, I think, for omitting error handling on the first example, because you don't want to be confused by all the other stuff that might happen. I mean, as everyone knows with programming, getting it to work at all is often quite a challenge. Any other reasons for missing out error handling? Khalil? Lack of context. Yep. As I've said to a few people when talking about this talk, getting the right answer is often clear and easy. You know what to do. You just return the number. What you do if it goes wrong, well, it depends. There's all sorts of contexts, and you're writing a general purpose blog or a book for a whole range of people using this tool. You don't necessarily know what the best and appropriate error handling strategy is. Sometimes it's because the function returns like close handle, it returns an error, and it's not entirely clear what you do with it anyway. And I suspect the people writing the documentation for this particular example may not have known. John?
Exactly mirrors the testing.
Sorry, say it again.
Exactly mirrors the testing, which also omits.
Indeed, it exactly mirrors testing. It's providing a good example of real-life production code and tests. And the other thing, of course, in our language anyway, and in many other languages, is there isn't a very good standard way of reporting errors. So we've got CER as about the standard way of reporting errors. Who's using CER in production code? One, two, yeah, possibly sometimes. Who's using something else? Okay, and who hasn't put their hand up yet? What happens with errors? You've retired. Yeah. Sometimes you see a step in the right direction, and I was quite taken by this one. So those of you who are biased against Windows, we've now got a different example for select. Well, here's an example. I mean, it is an example of select, and there is a return value for select. And if it's -1, it prints an error, and then carries on, and then returns exit success. What's wrong with that? Anyone got any, vague disquiet in their heart that possibly the error handling in this example might not pass code review? Although actually, it might well pass code review, because we don't tend to review the error path very well in our code reviews either. So the person reads the example code. There's error handling of a sort. It's not really thought through. It's not at all clear what the error means and what conditions could cause the error. It prints an error message using p error, but then carries on and exits normally. So if this actually were to happen in a real program, it'd be quite difficult. You'd see an error message disconnected from anything else, but the program returns success, so it's all good. So we're not really seeing good patterns to follow. So what I'm going to do at the end of the talk is take an example piece of C++ and just add error handling to it in a variety of different ways and see what falls out. But before that, I thought some sort of higher level questions we should ask. And the thing is, there's lots of things to think about. When we look at the possible ways you might have of handling errors, there's lots of questions we have to answer that we don't have to answer in the good path. Now, possibly in your company, in your team, or maybe even your own kind of working stuff at home, you might document sort of higher level answers to such questions in a kind of consistent fashion, so that it's very clear when you start working on the code base, this is how we handle errors in this project. Do any of you work on a project where there is such a document? Yeah, yeah. Why would it be an issue in the environment you're in? Is it just for fun, or is there actually a good sound reason for it? Anthony, anything you could say?
So so for the code that we've got, then yes, if something doesn't work, then, if it's an embedded device, then how do you report an error and who to?
Yeah.
What does it need? Is it just that you're going to log the error and continue? Are you going to reset? Are you going to somehow display something on the dashboard of the car and say, by the way, your brakes aren't working? No. What is it that you're trying to achieve by reporting the error? But how are you intending to handle it?
Yeah.
You need to think about that carefully for your context.
And some of that's documented in your environment, yeah. Alan, anything to add? Yep, pass it to Alan.
Yeah, so when the project started, the developers thought it would be a good idea to have consensus as to what each was expecting and what others would expect of them. So they got together and created a document.
Cool. Yeah, sounds good. So it might be something to think about as a takeaway, is whether there's such a document that would be useful to extract from your current project. So it's clear how you're supposed to report errors and what you do when things go wrong. One framework to look at is the one from journalism, the so-called 5W questions. Who's come across the 5Ws questions before? Oh, good, quite a lot of you. So who are you going to tell? There's lots of options when your program goes wrong. Who needs to know? Maybe more than one audience. What should you say? What are you going to report? And then when? When did it happen? And also, when should I report it? Where? Well, there's lots and lots of opportunities to put log information, error information in different places. Which is the right one for your context? And then the sort of meta question, well, why anyway? Why report them? What's the purpose of reporting an error? And then the question that all developers tend to go straight to, which is, and how? The details of the mechanisms we're going to use to report errors. And we'll come on to that with a worked example. But I thought I'd start off with the why question, although it's last in the list. Why bother to report errors? And why doesn't a lot of the example code bother to do it? So there's several different reasons. You might be reporting an error in order to give an explanation or justification for why you failed or your program failed to produce a meaningful answer. So think of a compiler. It's doing its best to turn your beautiful code into an executable. And you've accidentally written something that isn't really quite compilable. If it just stopped, you'd be a bit annoyed, because it's quite nice to know why the compiler failed in its task. Although my father-in-law did work on a system where the compiler would just print either nothing if it worked or a single question mark if it didn't, which is, giving it a justification for a complete failure, but not perhaps the most useful justification. Sometimes you're reporting an indication that I've produced your output, but it may not be very reliable. Something's overflowed, or I've had an error during the execution of the program. So these results may not be very, very trustworthy. And sometimes the error is to say, if you were to do such and such, it would be worth trying again. Possibly repeating this execution, or possibly reporting an error so that either the user or the programmer can fix a bug in the future. So there's quite a few different reasons why we report errors. And one of the problems with a lot of error messages is the person who wrote the error message has got one of those in mind, but not all of them. And of course, an error message, maybe you need to report a couple of error messages, one to the user of the program and one to the maintainer or supporter of the program, who need to know different things about what's going on. And then, well, who are you going to tell? There's all sorts of potential audiences for your error messages. You could tell the person running the program. How many people do that in the programs they work on? You give an error indication back to the person actually running the program. Yeah, very common. How many times have you been running a program yourself and you've got an error message that means literally nothing to you? Yeah. So although it's easiest to tell the person running the program, it's not necessarily the best person to tell. The next person might be the person who's going to use the output from the program, whoever that might be. So the output from the program includes some error information. So particularly if you're providing like numerical data that's going to be used downstream, an indication of potential problems with the accuracy of that data would be quite useful. And telling the person running the program may be less useful than putting it in the output so that it stays with the data and goes with it to wherever it's going. You could be telling the support team, something's gone wrong with the program, possibly something in the environment is needing fixing, or something is missing, or the network connection's gone down, or this program is just producing loads of errors. Somebody needs to do something about this, but it's outside the control of the person actually using the program. And then often you want to get a message back to your future self, fixing the bug or adding some additional error handling into the program, so the developers and maintainers. They don't want the same data very often. I'm not particularly interested as a straightforward user of a program that I didn't write in knowing the technical details about what went wrong. I mean, they are fun, of course, and interesting, but I can't actually do anything with that information. But conversely, the developer doesn't really want to know the kind of user level information. They want to know what went wrong in the code. So again, something to think about. And one of the, again, reasons why writing error handling in examples is quite difficult, because who are you going to tell and what are you going to tell is difficult to answer in a context-less small piece of example code. Sometimes it's something you can do now. Printer out of paper. Back in the day, put floppy disk in drive. Sometimes you want the technical details. As I said, normally you don't, but you often want something. I had this one out of OpenOffice a couple of days ago, and I thought I'd put a screenshot. General error, general input-output error. Thanks. What exactly do I do about this? Every time I open this document, I just get this dialog box. I've got no idea what the problem is. Well, of course, we're techs, right? So I attached a debugger and it gave me a call stack. So I'm guessing that my file wasn't really in good zip format, but that doesn't really help me fix the problem. If you're telling the user of the output of the program, they're probably not the person that actually ran the program. So you've got, again, got to think about what context do they need, if any, about the issue. They don't need to know just that the problem occurred or when in the execution of the problem it occurred, but which bits of data are affected. And you want to try and make it clear which bits of data are affected and the bits of data that aren't affected. I've seen, I work in finance a lot, and quite a lot of calculations fail for all sorts of random reasons. And in general, if you're aggregating an entire portfolio for a bank, you can't just stop because one product doesn't price. You've got to give some figures to the FSA. So people have got various ways of reporting errors. A very common one is 0. Yep. Is that an error or not? Yes. Yes. Or maybe no. So you get a price appearing of 0 and you think, should it be 0? I don't know. Some prices are 0 perfectly genuinely because it's some sort of swap or something and the net price ends up at 0. It's not that common, but it's very hard to tell zeros. Of course, it has certain benefits in that it just doesn't count in any arithmetic you do. You add all the things and the zeros just don't go into the sum. So slightly more helpful possibly is to put #nan. Any problems anyone sees with #nan in the output? Alan?
Yes, if you put that in the calculation, you'll end up with a #nan where you might not want it.
Yep. They don't compose very well. And I had a system I was working on about 15 years ago, and I realized that because of the way that they coded up some of the pricing, if you got an exception, it just caught the exception, logged an error, but the overall price was 0. And I thought, well, let's change that to nan because it would be more sensible to ripple the errors up. And we tried it, and the entire portfolio was valued at nan. every single book we drilled down to was valued at nan. So that was actually less useful than the previous data. One other alternative that people often use is an out-of-band value. 1 times 10 to the 300. It's probably not a genuine price. It would be a little bit expensive. 1 times 10 to the minus 300 is an alternative choice, but that is so close to 0, it's not worth worrying about. So a really high value. But again, you end up then with the problem that you're adding perhaps doubles together, and the actual values you're caring about disappear in the noise of this big value. So who you're going to tell, how you're going to make it clear it's an error, and how you're going to give them this information in a way that they can still do something useful with the non-error data. Not a question I can answer for each one of you in a general talk, but those are the sort of things you have to think about. And of course, for extra fun, you mix all 3 of those in the same program, just so that you've got no idea what's going on, which harks back to, if you've got a policy, it makes it easier for people to be consistent. People arrive on the team from a range of different backgrounds and different expectations about what you do when an error occurs. You might be telling the support team, do any of you work on a product that has a support team? Yep. Does the support team know as much as you about the source code? Probably not. Do they support multiple products? Yeah, possibly written in multiple languages, maybe. So they've probably got, I'm hoping, some sort of knowledge base, AI maybe, maybe not, that they can search for problems and then say, if you get this particular problem, then this is what you do in response. I discovered a little while back that the support team for the product I'm on have written a whole bunch of stuff that scrapes the log files. And they've got patterns they're looking for, and certain of the log messages trigger alerts, which is jolly good, but nobody told us. So if we change the format of the log messages, we're now going to be potentially changing their support behavior, which is unfortunate. We were trying to save costs, so we turned the logging level by default from info to warning, because it's now a long-lived project. And it turns out that some of the messages there were triggered big with only go off at info level. So we had to change some of them to be warnings, which went against my it's not a warning. So we've come up with a better solution, but how are you going to provide the information that the support team know how to handle this problem, particularly if it's a problem that occurs multiple times? Can you differentiate errors from different root contexts? Do you reuse the same error text in 27 places in your program? So they can't tell from the error message which of the things that can go wrong has gone wrong. Somebody was jokingly suggesting what you should do is add a GUID to every error message, which is admittedly a joke, but actually thinking about it, it's not totally stupid. Sometimes people do it by adding the source file and the line number in. Now, obviously, the support people don't really care what line number it is or what source file it's in, but it does give an unambiguous way of identifying which part of your program is coming from, except it's in the header file. So you have to can't just blindly do this, but think about what information would be useful to the support person. And is there enough context to do anything sensible with it? And if errors are linked together, have you got enough information to link things together? Again, and more genuinely, people often do this by adding something like a GUID of some sort to, say, an order as it flows through the system. And then every error message uses this same number, and now you can search and see the flow of messages through the system. So the support person knows which order was affected and then can work out, which customer they need to tell. And set your expectations about how much knowledge the support people can have. And better still, ask them and have a dialogue. Are our error messages and logs useful, or are there things that we could be giving you that would help your job easier? A, that's just nice for them, and B, it helps give better support, and C, it reduces the 3 a.m. phone call quotient. And then you want to get messages back to the developers or maintainers of the program. This is the eventual place where all the insoluble errors come back to, or the repeated errors that they think there must be a better way of handling this than just falling out of the sky. And there, you're wanting to provide as many technical details as possible. Ideally, you want to know, where am I? How did I get there? What data caused this problem? This takes time away from other development tasks. And you don't want to get error messages back to development too often, but you also want to make sure when they do get back, it doesn't mean the developer's spending an awfully long time trying to work out what's going on. Most of the things in the message the developer wants are of no use at all to the user. So again, you might want to think about different error paths, different error channels for sending information in different places. And then, so what should you say? What should you not say? A little bit of context can be terribly, terribly useful. A lot of languages give you a call stack. Who finds call stacks useful for debugging? Yeah. Just, how did I get here? Breadcrumb trail. What actually is the details of the problem? So I've got a couple of examples here. I tried the same thing on 2 compilers. Accessed a vector off the end with the debug runtime library, and in one case I just got invalid vector subscript. Next one I got vector underscore m underscore range check underscore n, which is 8, is bigger than or equal to this dot size, which is 5. Okay. What I really want is a sort of synthesis between these two. I like the fact that the first error message is readable, but I like the fact that the second error message tells me that 8 was the index and 5 was the size. So now I've got some hope of working out what's wrong. The example I also use elsewhere is file not found. Which file? When you're writing the error message, you often have that information there in the code, and you know exactly what the file name is because it's there as a variable 3 lines up. Think about the error message. Who's going to read the error message? Which of the bits of local state you've got would make sense to add to the error message? What sorts of information could you make? Well, an error message can be quite handy, something that's readable, but it's not very structured. It's quite hard for automated tools to handle. A replayable data set can be really handy. As I think I said at the early careers day, I worked on a project that distributed pricing tasks across a grid. So we did, every time the pricing task arrived, we wrote the binary to disk. And then when it completed, we would delete the file. But if it didn't complete, we had the data set sitting there on disk, and you could then replay that data set and get the same, hopefully, the same failure. So think about which data you might be able to store, and the other problem is, where do you put it? It's no use if it's sitting on a production machine that only production support have access to if you can't get the data out. If it actually goes completely horribly wrong, a crash dump can be useful. What sort of things do you think you might need with a crash dump? Debug symbols? Who's like debugging crash dumps with no symbols? It's fun, isn't it? Yeah. So you may or may not want the users of your program to have the full set of symbols for your program. I don't know, it depends what you're doing. I worked on a program a while back, third-party product. We came up with a problem. If we relocated the DLL in memory, the prices changed because the return address was appearing as an uninitialized double, and at low memory it was a 10 to the minus something, and at high memory it was a big number. So we managed to work out the source line number and the name of the structure and the name of the field in that structure that they weren't initializing. which is jolly handy because we could say to them, you need to initialize this element of this structure on this line in this source code. But then I was reflecting on thinking, that's really quite a lot of information you can get out about a piece of third-party code. So you might not want to ship those debug symbols to your customer, but keep them somewhere private where you can attach them when the debugger's going. The other problem you've got is data privacy, security, access issues. How many of you are dealing with data that isn't publicly available and would cause a GDPR issue if it just sort of appeared out there? So if you've got a memory dump or log files, there might be information in that that has to be managed more carefully. So again, the classic case is logging password changes. That's always good fun. This connection to the server failed. You know, user ID, password, URL. Thanks. Now I know the production password. I don't think I should know that. And then when did the problem occur? It may be you just get one error, in which case it may not matter very much. Very often you get multiple errors, and you'd quite like to be able to know what caused what. And accurate timestamps are really important. Particularly, how many of you are working in systems that span multiple machines? Microservices or, are there all the timestamps synchronized? Should be. Are all the time zones the same? Well, there's only one sensible timestamp. UTC. And actually, the red Z, or Z if you're American, on the end of the example, that means that not only is it UTC, but also it's obvious to everybody that it's UTC. I have worked on systems, Google Cloud, I'm looking at you, where the time zone doesn't have any indication in the display of timestamps you get by default. So I'm looking at the screen on a screen share, and then I suddenly think, oh, of course, he's in Poland. What's the time difference? I don't know. What's the difference between Poland and London? And it's around the daylight saving times. Are they on the same? Stick with UTC. But you may, of course, need to display it. Again, looking at the audience, who's going to see the message, you may want to display it to them in a format that makes sense for their user behavior, which is, I don't care about UTC. I have no idea what that is. I want to know it's nearly lunchtime. And again, when you've got multiple errors, you might want to defer reporting the error until you've gathered more context. So in a call stack, you get an error way down at the bottom and you've got no idea. You've just tried to open a file and it's failed. Well, what is this file? Why do they want to open it? Is there anything that can be done in response to the file not being openable? How do I know? I can't tell. Well, I'll report the error up, back up the call stack, and each level you could add additional context. And then at the top, you know not only what the file was and what the file system error was, but also kind of how I got there. And in a data flow, you could attach error to the message as it flows through the system. So by the time you get to the end, you've got the error, but additional context about what it meant, how it occurred. And then report the whole thing in one go, so you don't have to try and collect together 17 different messages in 6 log files on 4 machines in one place. Admittedly, the tools get quite good for some of this, but why make it harder for yourself? And then where should your data go? I mean, knowing where to put it is obviously important. It may constrain what you do. You're in a UI component running in a browser. Where shall I report my error? Well, I'm in a browser, so it probably makes sense to report it in the browser. I could write it to the log file. Does your average user know there is a log file? If so, where is it? How do I access it? Perhaps I can write it to a centralized error repository. Do any of you have such a thing where you are? Yeah, where you report errors centrally. That can be good. But does the person who's running the program get any indication that something's gone wrong? And if so, do they know, or do you know, how to find that error message in the repository? you can end up with a repository with literally billions of messages in, and tracking down, I'm trying to find anything that went wrong between about 1125 and 1127 on one of goodness knows how many machines. Oh, there's loads of things that went wrong. Which one was my problem and which one was somebody else's problem? And the problem is you tend to develop the software in isolation, very often don't actually run it in a production-like environment, and you don't discover these problems until it's already out there and you get your first problem, and you don't know how to get hold of the log file. Oh yes, I've written to /temp on a machine. I wonder which machine. And I wonder whether the machine's even still there, or whether it's been ripped down by Google Cloud or something. So thinking about these things up front is very important. The other problem with a UI component is what happens if you get multiple errors. The first one is really obvious to the user. And if they're like my daughter when she was little, you just press OK, and then it's like, something went wrong, Dad. What was it? I don't know, I just pressed OK. They're not very persistent. And the other problem is, have you ever had the case where the program you're running on has kept producing error boxes? Yeah, and they either cover the whole screen and it runs out of stack, or every time you press the button, you get another one, normally in a slightly different place on the screen, so you can't just keep clicking, you have to move the mouse and click. Who finds that really, really frustrating? Yeah. So again, think about it for your poor user. I did work on one program that they did very well. They had a single dialog box that told you the error, and if another error occurred, it would just be appended to it. You had a list that you could scroll down, and then a single I've done button. And it's also particularly helpful to think about using some sort of UI if the user can actually do something to fix the problem. Of course, one of the commonest places we use is log files. Very common IT solution. Put it in a log file somewhere, choosing where. Maybe there's a convention, maybe not. One of the problems with log files is it's not obvious necessarily to the user of the program that this log file even exists. Have any of you, I'm sure many of you, have been in a situation where you're running a program, you get problems, you finally get hold of somebody who understands the problem, and they say, have you checked the log files? And you go, there are log files? Where are they? And they give you some path about yay long. You think, well, that's why I couldn't find them. They were buried underneath some directory. So again, thinking about making these things visible to the user. And log files can get quite big. How long do you keep them? What do you do with them? Do you delete them? Do you put them in some repository? Do you try and make them searchable? Questions to think about. So a lot of places end up with some sort of centralized repository, and I've mentioned this can be positive, single place to go, but it can be negative because it can be finding a needle in a haystack. So if at all possible, try and think about it, try and play with it in practice. Is there some way of making it much easier to search for things, giving it some sort of unique ID or identifier that you can find again? Those are a few things to think about on the 5 Ws. And now we'll start looking at the how. And I originally thought I'd have a much more broadly based how, but actually it takes a long time to do error handling, which is another reason for not bothering with it in the textbooks. It adds a lot of extra complexity. So I'm going to start with a fairly simple bit of code that has the classic industry standard no error handling, and then think about what we might do. And I'm sure that you'll be able to come up with all sorts of approaches to handling errors that aren't covered in the slides, because there are lots and lots of different approaches to handling errors. So I thought I'd come up with a simple example of a class generator. It's got a method to configure it. It's got an accessor for size, and then you call the function operator, giving it a count, and it returns you a string of that many characters that it's generated for you. And then privately, there's some data. So it would be used something like this. We configure the generator if we've been given a config file. If not, we use some sort of defaults. We've put in some debug information to print out how big the generator is, what's the maximum size it's got in its store. And then we just go through reading in from the user what length they want the word to be. And while we get that, we call the generator to get a letter of that number of letters in the word and print it out. Very, very straightforward, simple example. But even with an example this straightforward, there's still an awful lot of things you can say about error handling. So let's look at how you might implement the configure one. So we start out, we're given a file name. So we're going to need to open it. So let's create an input file stream. And then we'll go through calling getLine, line at a time, read in a line. We'll see where the equal sign is, split the line on the equal sign, and read the letter A, Z, Q. And then the second half of the line is how many of them have I got in my configuration. So you might have A equals 3, B equals 2, Q equals 0, and it tells you how much to populate. And this code has no error handling, so obviously nothing can possibly go wrong. And then when we read all the letters in, we then just randomly shuffle the contents of the generator. So when we start asking for the 3 letters to make a word, it just picks out the next 3 letters in its internal buffer. And so we've got a couple of simple accessors. The size is the size of the value less the number we've read. So it's the remaining size. And then the function operator just reads out the next n characters from the internal buffer. And I'm sure you're all thinking of all the things that can possibly go wrong here. There's quite a lot of them. And one of the problems with writing programs is nearly everything you do can go wrong. And also, nearly everything you do can go wrong in more ways than you remember at the time. So there's the things you know can go wrong, and then there's the unexpected things that you forget or didn't ever know could go wrong. So one thing we could do is we could start writing some comments. I have to rethink this slightly, because with the talk about AI and AIs read comments may be more useful than I had thought. But with a compiler, they don't read comments yet. So what I've put in is maybe I couldn't open the file. I mean, there could be all sorts of reasons for that. It doesn't exist, or I haven't got permissions, but I couldn't open it. Maybe getLine fails because there's an I/O error. I mean, I/O errors never happen on modern disks, do they? Maybe there's no equals character in my line. I mean, I'm reading a line of data from a file that somebody gave me, and maybe they've possibly just got a syntax error in what they wrote. I'm going to call substra. I might get a bad alloc exception because I've run out of memory. Might get bad alloc exception in various places in this. I'm ignoring that for now completely. We'll maybe come back to that later. I maybe didn't get a single letter. Rather than typing A equals 3, somebody wrote ABC equals 3. That's not valid in my simple grammar. And then I've just called S2I on value. Well, maybe they've put magic rather than a number. What would S2I do with the string magic? Can I remember? I might forget that. That may throw as well. So that's documented the code, but not very helpfully. Perhaps I could go through and actually just change the error messages, the comments into error messages. So rather than it being a comment to the reader of the code, it now becomes a comment to the runner of the program. They're both effectively still comments. They're just giving you information to read. At one time it's at runtime, and the other one is at compile time. In some ways, philosophically, you could argue that this is the same example. You could just extract all the comments from the source file and give them to the user and let them work out which one occurred. But we could say, couldn't open the file. For simplicity, let's start with CR. I write out, well, I could be helpful and just say didn't open. Or I could say, here's the file name. Of course, what I want to be able to say is I couldn't open the file because. But unfortunately, there doesn't appear to be a standard way of getting that information out of IF stream. And then I go through and I decide I'm going to print out an error if they don't give me a single letter. So the letter, and I put it in quotes, so that if it's something weird, like a non-printing character, there'll be a hint, perhaps, that there's something strange going on, or unrecognized line. Now, again, I've written here no equals character in the comment and unrecognized line in the error message. Maybe I should have written no equals character. Maybe I should have written unrecognized line because no equals character. And even at this point, you can see there's loads of different ways of answering the simple question of how do I best handle errors here? Who would prefer to see the error message say no equals character in line? Yeah, I think I would too. Who prefers unrecognized line because that's explaining why the missing equals sign is the problem? No, I haven't persuaded you, have I? And then I'm actually checking whether the stream is good at the end to see whether there's been an IO error. One thing about this is the program doesn't do anything different in response to an error. So, okay, I couldn't open the file. It still goes on and does the while loop. It reads a line and there's no equals sign. It still carries on and processes the data. Is that good or bad? It depends. And again, one of the other things to think about with errors is what should I do when I detect an error? Should I stop, for some definition of stop, or should I attempt to do what I can? And once more, it's really hard to give a single answer to that because it depends on your context, what you're doing. One of the things that was voted in at the last standards meeting into the standard was contracts. Who's aware of contracts in C++? Who's aware that it's been perhaps not uncontroversial? Yeah, long discussions, like 5 years of SG21. I mean, Timur was a young man when he started it. And loads of different viewpoints and people with strongly held views that in this environment, this is how a contract violation should be visible. But in other contexts, that's completely inappropriate. And this behavior is required. And managing that range of requirements is far more difficult than managing the requirements of how things should work when they work. One of the problems with this is it comes out in CR, which may be appearing in a console near you, or it may just vanish depending on where this code is fitting. Anyone written UI programs where CR just goes to the great bucket in the sky? Yeah. And so sometimes you have these terrible tricks. I think somewhere I worked actually had a program you ran that you gave it the UI program as its argument, and it captured cout and CR and wrote them to the console just because there were so many programs out there that wrote to CR without really realizing that there isn't really a CR visible in a UI, and it's kind of handy if you can see it. The other problem is the messages are free form. It's quite hard to drive further behavior from the messages. And also being free form, if somebody decides to change that error message from unrecognized syntax to the one that you seem to prefer of no equals sign, they won't recognize the new error message if they've coded their behavior on the text in the message. And the other thing is CR is a little bit primitive. You may well have access to a logging framework. Who's got a logging framework in their project? Yep. I bet you haven't all got the same one. But a logging framework, which lets you decide how errors should be handled and perhaps to configure for each given program, where they go, what sort of destinations they go to, what sort of logging levels you decide are important and which ones are going to be shown where. So that's reporting the problem. Well, going to the other end of the spectrum, we can do reporting by exception. And I didn't bother to put anything in here about performance because Khalil did his keynote all about that. So we can know about how to make exceptions faster and use less memory and less instruction space. But we can just look at what actually happens when we report an error by exception. First thing is you throw the error. So it's a control flow change. With the error handling we've added so far, nothing's changed about the behavior of the program. It's just chattier. Obviously, I could, in the if bits for the error handling, have done something different like return, but I chose not to. With a throw, you don't get that option. You can't say, I'm going to throw this exception later. Well, not without writing code. It just throws. So a bit like the discussion we're having in some context earlier in the week about returning a value, but also doing control flow, throw is the same. It throws something, but it also definitely throws. So it may not be the right tool for your particular problem just for that reason. You can't separate the error object from the control flow change. We might write our own exception classes so they can capture additional information, stuff that's domain specific, or we might use standard exception hierarchy. So I'm going to start out by using just stood runtime error. Just for interest, how many of you are using exceptions in your programs? Yeah, it's quite a few. How many are not ever under any circumstances? Yeah. How many are it depends? Yeah. And who's using standard exception classes from the STL, the standard library? Yep. And who's got their own exception hierarchy? Are the exception hierarchies of your own derived from one of the standard exception classes or not? Yeah, so you've got a few that are not, majority who are, and quite a lot of people who are using standard exception classes. Again, it depends. One of the nice things about deriving from the standard exception classes is you can defer the choice to later. One of the downsides, of course, is you can't tell easily your exceptions from the other exceptions. So it depends. The nice thing I found when writing this code, and I actually found this was great fun doing this because I'd never done it before, which is to take basically the same code and add error handling in multiple ways. And the nice thing about exceptions is the happy path doesn't need changing. So it's a much easier thing to add. So reporting by exception, I just put in, I haven't extracted all the code here, it stops fitting on a slide, but I've just thrown a runtime error, letter is not a letter. And again, with there's no equal sign, I've thrown a runtime error, unrecognized line with the text. And nothing else has changed. What needs to change in the caller?
With the try block.
A try block. Does it need a try block?
Something needs a try block.
Something needs a try block. Yep. We'll see what happens and what the way is of handling it. A couple of other things about reporting by exception. The first is, logically, we've now got multiple exit points. Single entry, single exit. Who's heard that acronym before? I think it predates block structured languages, and it was for things like assembler where you could jump in to code at various places and jump out at various places. Once you get exceptions, worrying about single exit seems to me pointless because you are having multiple exits, because every time there's a potential of a throw or something you call throwing, you're coming through another control throw through your program. So if you're absolutely passionate about single exit, you probably don't want to use exceptions. But putting it on its head, one of the reasons for wanting to have a single exit point is to make sure that everything is nicely tidied up, that you've reset things, that you know where things are going. And now we've got exceptions being thrown, so you have to make sure that's the case all the way through your program at any point where you might throw an exception. So although I didn't change anything in here, in general, adding exceptions to an existing code base, you may need to change things. I had a case some years ago where we were doing perturbation for checking how the price of an instrument would change if market conditions modified. So they pass in a mutable market object to the method. We bump one of the curves, reprice, and then bump it back. You see what's going to happen. If the pricing gives an exception, nothing unbumps the curve. So it just remains bumped. Once we found it, of course, it was easy enough to fix, but it's having that mindset that if you've got exceptions, at every point you might exit the function. So you can't rely upon sequential flow. You have to use things like in C++, we've got RAII to do that for you, to make sure things get unwound properly when you leave. And the other thing about it, as I mentioned, is that the thing about the way I've written it there is if you get a single syntax error in the input file, I'm going to throw an exception at that point. And so nothing further will happen to that file. I won't read any further. Is that good or bad? In particular, if I read all the way through the context, the config file, and the very last line was an error, I'm going to bail out with an exception. Now, I could handle it and just say I couldn't configure, but I haven't completed the job. I haven't done the random shuffle. So the letters are going to be in the order they were in the config file and not shuffled. So again, the behavior of this small piece of code is radically different in the presence of an exception than it was in the presence of logging to CR. Now, going to the caller, they don't have to change. If they don't need to be resilient to runtime problems or have no idea what to do with a runtime problem, they can just be unchanged. And the exception just bubbles up the call stack until it either falls out and your program crashes, or it finds a catch handler. And anyone on the call stack, either the direct caller or somebody intermediate, can choose to opt in to catch exceptions. And they can write a catch handler that just catches the ones they care about. Or they could say, well, I looked at the exception, but I didn't know what to make of it, so I'll just rethrow it, and it will carry on up the call stack. But in this particular version, everything I threw was a runtime error. So it's going to be quite tricky to write meaningful code to differentiate between bad syntax and missing file. And there's obviously quite a big difference between what you might do in response to those. Missing file, you might want to prompt the user for, I couldn't find that config file, give me another one. Bad syntax, well, there's no point looking for the file again. You found a file, it's just got bad data in it. And the other thing is you might catch something you're not expecting. So I mentioned the S2I will throw. I didn't write anything to do that. It does it all by itself, but that will again generate a standard exception in the STD exception hierarchy that will be part of the mix of things that somebody might catch further up. So we decide we'd like to add a try-catch block. Well, what we can do is we can use main. Yep. Question from Alan?
One consequence of using exceptions you didn't mention on your last slide is that the multiple exit points applies to everything on the call stack before you hit the...
Yes, that is a good point. Alan was saying that everything between the throw site and the catch site has an additional control flow. So even if your little function doesn't appear to use exceptions, if it's in an environment that does, you need to have the same careful thought about what happens if an exception flows through me. So we decided we want to catch it at the top level. So we go try, we call process. Process under the covers is going to do the configure call. We don't want to bother to change that part of the program. The exception will just ripple through process and appear in main, and we catch the exception, we log out, an unexpected error occurred, print out the what string, and return an error. So we've done something, perhaps not very sensible, but we've done something with it. And the nice thing is we haven't needed to change any of the intermediate functions. In this case, we've only got process, but it could be quite a big hierarchy. And the error handling just works and goes from the bottom point right up to the top point. But we might decide to extend that by adding some of our own exception classes. So I've just done something very, very simple. I've just decided to have a syntax error, an IO error, a cannot open error as a subclass of IO error, and a request error, and just make them all derive from runtime error. Nothing particularly clever. I mean, life's too short. I could have added all sorts of additional data that you might want, but it seemed getting a bit over the top at this point. And then all I do is I change my program that I throw syntax error in these cases, and obviously a file not found error if I couldn't open it, or an IO error if IFS returns false further on. And nothing needs to change in the caller. It still doesn't need to handle exceptions explicitly. All these different classes of exception just go through till they find a catch handler or bubble out at the top of the program. And you don't have to differentiate the errors. You can still just keep with your catch stood exception. If you're not interested in the differences between the different exception classes, you just don't bother, just catch the most general case. But it gives you the option, if you want it, to be specific and say, I'm only interested in handling syntax errors or can't open errors. So for example, we could call try, process the file name, and if we got a cannot open, we prompt, can't open this config file, choose another, read another file name in from the user, and go around and process that one, see if that works any better. Okay, all clear so far? Cool. Well, there's more than 2 ways of handling things in C++. Who'd have thought? We could return an error, which is, again, one of the really common ways in C++ that we return errors, and one of the very common ways that functions we call, operating system functions, runtime library functions, return. They return an error or a status or something. There's quite a few different ways of doing it. Let's talk through some of them. Simplest possible way I could come up with was let's return a Boolean. True, false. So the signature changes to I'm going to call configure, it's going to return a bool. By convention, I guess true means it worked and false means it didn't. That hopefully is obvious. If it was int, that's more interesting. Does 0 mean it worked or 0 mean it failed? Yes. And in the caller, you have to remember to check. So let's see what we do. We've got bool configure, small change. Now, if we don't change anything, what happens in the caller? We just call configure. We throw the return value on the floor. Does anyone notice? Maybe you'll get a warning from the compiler. And particularly if you've got like no discard attribute, you'll get a warning you did nothing with this. But very often, you forget to check the return code and nothing bad seems to happen. So there's nothing making you do it. But if we are good, we can check whether configure worked or not. And if it didn't, we can say, well, here, I've guessed. Can't read config file. Well, maybe I can read the config file, but it's got rubbish in it. Or I read the config file and halfway through I got an IO error. So the problem with the status value is you've got to think carefully about how rich a status value do you want to return. Now, bool is the minimum. It either worked or didn't. And that may work in your environment, or you may need a bit more than that. So we've returned false if we couldn't open the file. We've also returned false for not a single letter. And there's no way of telling from the outside which has occurred. The other thing is that the value comes back in band. So it's in the same path that the good return uses. And as I said, if you ignore the return code, the program still appears to work. And you might want to think about something richer than bool. There's an interaction here with single entry, single exit. If you are returning a bool, you've now got an option. Unlike the throw case, you could choose to defer the status to the very end of the function and just return an overall status. So you've got the possibility with a status value, which is much harder to do with an exception, of doing more work after an error has been detected. Whether that's right or not, only you can tell, but it's an option. So we could, in this case, set an error to true, and then set an error to true if we read something not a single letter, and then at the end, just return whether or not we've seen an error so far. Or we could count errors. So we've got more choices here because we've separated the control flow from the error handling. Of course, you can do both. You can return a bool and log. This keeps the logic of the program quite simple because you're still just returning a single value. But it means if you want to process the error in a more intelligent fashion, you've just made things harder because you've got to detect the error with the Boolean status and then find the error in the log file or whatever data structure you've written the logging in. And it can be non-trivial to work out which of the messages goes with the bad status you got. So we could, for example, in here, we could log the same error message we had before, that we can't open the file name, and then return false. Or down here, we can log that we can't, value isn't a single letter, and return false. But it might make it hard for people to work out which particular message in the log went with which error. An alternative on returning a bool is to keep an internal state that's convertible to bool, possibly with an implicit conversion to bool. IOStream's library uses this, so we're very familiar with that. You read stuff in and then you just check the state of the IFS input file stream object. And it works quite nicely with what I've just kind of said as a fluent interface, where you do multiple things on the object, and then at the end, you check its state, rather than having to check every single operation. So it's just a sticky status. So let's see how we would do that in this case. Again, many ways of doing it. This is one way. You add an operator bool, const operator bool to your class, and what we return in this case is a Boolean error underscore, which gets set to true on the false error, whatever. And the effect on the caller is we just go through and then we just check if not generator. Of course, this then immediately makes it harder to share the same object because you can't detect what set the error. Was it in error before I started, or did it just get in error because of what I just did? But, you know, it's often quite a useful pattern. And then all we do is, again, if we get errors, we just keep setting the flag as we go through. But again, we've got the option. We could set the error flag and return, or we could just set the error flag. And then, do we actually need to be able to reset the error condition? Well, possibly, but what does it mean to reset the error condition? It's in error. What do I have to do to reset it? Can I just tell it, clear that error flag? I'm sure you're fine. But the error was it couldn't read the configuration. So maybe it shouldn't be possible to clear the error. Hard to answer in general. So those are some of the things to think about. Maybe you should say you have to call configure again, and the next time configure is successful, the error status is cleared. Or maybe you just provide a method called clear that resets things to a known good state. And the other problem is, if you don't check the status, you just carry on without ever realizing that a problem had occurred. So moving up by one from bool, we might want to return some sort of status value which gives a bit more information. We could, for example, have an enumeration. So, okay, can't open, not a letter, unrecognized line, IO error, as many as you want. And then possibly add a helper method for streaming those out in a textual form for the human reader, whereas the computer will be dealing with the enumerated values. And now the status changes so that configure returns an error, and the effect on the caller is you just check whether you got an error or not. Error not equal error okay. Of course, conceptually, this means that every call to configure returns an error. which metaphysically is perhaps unhelpful. And there's also the issue that implicit conversions, if you've got an old style enum, means that you could end up checking things that aren't appropriate. But it can work, gives you a bit more information. And then in the code, we just return error cannot open, error not a letter, error unrecognized line, you know, as I'm sure you expect. But I get error cannot open. Cannot open what? I get error not a letter. What's not a letter? This is slightly better than a bool, but not, to my mind, a lot better than a bool. I normally want more information than just a status. But the enum is very handy for code that has to decide what to do, because the code probably doesn't care what the syntax error was. It just needs to know there's been one. The other approach is to say, well, let's just return a useful string. Rather than logging the string to see error, I don't know where to log the string. I'll just pass it back to the user and it's the caller, and it's their problem then. So you can have an error message that contains additional data. It's possibly free form, put what you like in it. And one relatively common pattern I'm sure many of you have seen is you just return a string, and if it's empty, nothing went wrong. Anyone else seen that one? Yeah, an error string. So we change the signature to return a stood string, and then in our calling code, we capture the string in an error message, and if we got something back, we've now got the error message to log, and everything in the garden is rosy. So we're using the same error mechanism here as we were in the early example, but if this was now embedded in something else, we could log the error message by sending someone an email, for example. So we've decoupled the error detection from the error processing. But once again, it's difficult to automate this and put it in your program because you've just got text strings to play with. And again, it's up to us to make sure that the message in the string is meaningful. Cannot open file name rather than just failed to open, or such and such is not a single letter. And the problem we've got is that the status object being a numerical value is great for the computer and control flow, but less good for people. And the message string is much more useful to read, but harder to program. So we could just return an object with both in, make the best of both worlds. And this status object could itself benefit perhaps from a conversion to bool. So we'll define a simple status object, default constructor, and it can be constructed with one of these error enum values and an accompanying error message. And hand waving a little bit, the error first argument is designed for the computer and the text is designed for the user or the person reading the logs or getting the error message. Bit hand wavy. We've got an operator bool, so you can say, is this status object reporting an error or not? And again, we might want to add a streaming operator to it, so it's easy to, in turn, log this status message. And so again, the signature changes very subtly to put status as the return type, and the caller, again, now generates a status object in response, and then checks whether there was a bad status, and if there's a bad status, you can now log out the status, and that error display may well include both the enumeration constant and the string, or your choice. And then in the code, it's getting slightly more complicated because we're now having to generate an object. I'm using brace initialization here with the enumerated value and the whatever the message is that goes with it. So in the case of not a letter, I'm going to pass in the letter. And in the case of the missing equal sign, I'm going to pass the whole line in. And then in the code that turns the status object into a string, I know what I did, so I can decide how to interpret the payload each time. Okay, so that's a range of different options we can do. And that's just for the configure function. There was more than one function in our interface. I picked configure to start with because it had a void return. How about non-void functions? Something like the function operator that we had, function call operator that returns the string. Well, we're already using the return channels. So what can we do with things like the function call operator already returns something? Well, one way is we can make use of an alternative return channel. We could use an output parameter. Who's ever used an output parameter? Yeah. Who thinks they're brilliant? Who thinks they're awful? Who thinks it depends? Yeah, a mix of hands. I think more people thought they're awful. But we'll start with that because it's very common. We've got exactly the same set of choices as for the return type because, again, we are logically, an output parameter is a return. I've got a problem. You see, we've got this void method that we've now hijacked the return path for the status code or whatever, and we've now got this function that returns something. So should we be consistent and use the same pattern everywhere? And so should we keep configure as void, but pass the out parameter for the error? Or should we make configure return an error as a string? I don't know. I personally prefer to make things consistent because I like to know where I am, and if the interface to a particular class always does it the same way, it's easier to get it right. And then in terms of the caller, what you do is you call generator.configure, and now we've got an output object that's been populated, and we check the output object, and we can do what we like with the output object. One of the problems with this style, of course, is I've got to create the out parameter to start with so it can be populated, which is unhappy. And the second problem is if I don't do anything in the check, I've again got the same as ignoring the return code. The error has disappeared as far as I'm concerned. And also, what happens if I pass in a non-empty string to configure? Will it clear it for me, or will it just return whatever I passed in on the happy path? Anyone ever been bitten by this, where you call something that populates an out parameter and you pass in the out parameter from an earlier call and it just leaves it unchanged on the good path? Yeah, yeah. It's a bit like the same problem with Erno in the C library, that if you don't clear it first, then you don't know at the end whether it's bad because of something you did or because of it was bad before you started. A question over there? Just wait for the mic. Yeah.
Thanks. Thank you. But shouldn't, in those cases where you have error as an out parameter on a happy path, that variable should not be touched at all? Because that's what happy means, that the error is not interactable, doesn't have to interact with it?
Yes, you've got a design choice. Again, if you've got a fluent style of programming, it's quite nice to set up a single error status object and just pass it to 27 calls, and at the bottom you say, did I get a problem? And so you can argue that the good path shouldn't touch the error object, but in other cases you wish it did, and unless it's well documented, you don't know which it was until you try it. So it's one of the problems with out parameters that you don't get with return codes, because you have to get something back and it's up to the function to decide what to return. So what we do is we just pass in a non-const ref and just assign to it. And again, we've got the same choice here. We've reported the error, but we've got the choice as to whether we carry on or return. So we've managed to decouple the error reporting from the control flow. We've got choice back as to what we want to do. And the other problem, of course, is this wretched problem of trying to create the object before you start. And should it be an accumulator or should it reset? It's hard to get that right. Another way of handling the side channel is, rather than using the return value or an out parameter, is to use some sort of internal field. Have an internal field where the last error will be returned. And then effectively that's an implicit out parameter, and then you can query that later. So we could have a method, say, last error, that gives you access to that object. But again, it has the problem that if you don't know about that last error status and you've never called that last error method, you never get notified that there's been a problem. But here it is in practice. You've just got, we call the last error function on generator every time we do something that we care about to see whether it errored or not. We can return, we're returning two things. Well, we're returning, did it work? And if it did work, here's the value. So you could use an optional, which is quite a good way of handling this case. So if we pass an optional back that's been populated, it worked and here's the value. And if we get back an unpopulated optional, it didn't work. You could also use a pair or a tuple or something, but I think optional probably better expresses intent here, or maybe your own type that does something similar. We're going to come to that. Yeah. Well done. Your check's in the post. So the effect on the implementation, we've got an optional string when we call the function call operator. And if we've got too much data requested, we've asked for more data than is left, we just return empty braces. And if we did get the value, we just return the result. So again, it's quite readable in the code, reasonably simple to do, a fairly small change to the interface. And then in the caller, you just save the value away and then check whether you got a result back or not. But again, it has the problem with an optional that if it didn't work, you don't know why it didn't work, just that it didn't work. You've got the choices again with an optional. If you don't want to bother with errors, you can just use the safe call that throws. So if you call value, if you didn't have a populated optional, you'd get an exception. So it maps from the optional model into the exception world kind of transparently. Whereas if you just use star, you get undefined behavior. Something will happen. Who knows what? And as I said, you don't get any additional information, a bit the same problem as returning a bool. And also there's a little wrinkle in it. You can't currently have an optional avoid. You can try it if you like, but you'd far better not to. And so you can't trivially use the same error handling mechanism for your configure method that returns void as you did for everything else. So you can't be consistent across your entire API surface. So we could return an expected. Who's used expected? Good. Who thinks it's really good? Nearly as many hands going up. Who thinks there are problems with it? Few hands go up. Yeah. Who thinks we might fix the problems? We can hope. So what you do with an expected is you define two types. There's the good type and the bad type, or the expected type and the unexpected type. And unlike optional, you can have the good type being a void. So there's a specialization for a void, which is quite nice because it means you can use the same error handling mechanism for everything. You can be consistent. So on the implementation side, we change it to return a stood expected of in our case, string and string, which is a little problematic for the reader of the code, but you know. And if something went wrong, we return a stood unexpected with the payload being the message we're going to display or handle. And in the good case, we just return the result. And it's very clear, because of the stood unexpected in the code, what the unexpected places are. The good path doesn't change. The return result was exactly the same as it was before. And you can, if you want to, just treat it as a bool, or you can do something with the return value. Or you can do something cleverer and use the good and bad values. So we can get the stood expected of string and string result, and then say, if the result hasn't got a value, I've got a problem, print out the error message in our case, because the second argument was a string. And again, if you use the star operator, please make sure you check that you've got a good value in the expected, or you can use the dot value if you want to map it into an exception. And it does seem to be quite a good fit for the return category of error handling. And there are additional operations that I haven't got time for, looking at the clock, about writing code that change things together and passes code along a set of operations. So we've got a couple of little examples. And optional has the same operations, or very similar operations, so you can do the same thing of chaining things together. So you can, for example, use the generator and then dot transform error to make it differently readable. More readable to some people, less readable to others. So again, check your other programmers. What style makes sense to them? Depends on where they come from. Maybe they just need a bit of training, or maybe you just better go back to something that they do understand. And all the return issues that we've done so far, whether returning directly or returning from an out parameter, have nicely sidestepped the little problem of S2I, which is still sitting there in the implementation and will still throw an exception. Nothing to do with my nice expected handling or anything like that. So we still do need to do something. We may just choose to map the exception into whatever return type we're doing. So, for example, we wrap the call with S2I in it in a try catch, and then map the invalid argument to our own stood unexpected message. But we've got to make that choice. We've got to make that choice everywhere an exception is thrown. Or we decide to have exceptions and expected. Who thinks that's a good idea? Not a lot of hands going up. It may be the best solution, but it makes error handling doubly complicated because you've got two error paths to check out. Dealing with exceptions, there are many places where an exception can be thrown. As we said, you've got to think about that. If you didn't spot one and you get an unexpected exception, I mean, all exceptions in theory are unexpected, but one you didn't program, the good news is that it still goes up the call chain and hits a try block, or one that will actually handle it. The bad news is that might mean your program crashes when you weren't expecting it to. And the other problem you have with exceptions is that some environments don't let you use the exceptions. How many of you are working in an environment where exceptions are just not allowed? The runtime doesn't support it. Yeah, there are a few. So you can't use them. And my view on passing on errors with a return code is I think expected looks like a really good way of going. The other approaches are all still there, but it does seem to be scratching the itch in the right way. But one of the problems with them, and there wasn't really time to demonstrate a bigger hierarchy, is it's viral. If I want to return an error through several intervening calls, I've got to kind of write the error handling at each level and pass it on up and pass it on up. And one of the questions I had looking at Khalil's presentation with the cost of exceptions versus error handling was, what's the cost in the good path? Because I don't think that was mentioned. Because you've got to do a check for whether or not you had an error all the way through the good path of multiple levels of function. And you may never get an error. It may really be rare. And so you're wasting all this time checking for errors that didn't occur. Whereas with an exception, nobody checks for the error. It just goes when it's caught, then it's handled. But the rest of the time, you're not covering it. So in conclusion, I can understand why error handling is omitted. That's a whole talk on just two functions, putting in error handling. And I haven't even covered all the other ways other than stood at CAIR where you might have reported errors. But think about it. Think about whether there should be a better way of handling errors that you should document in your own code base. And be aware that there's not just one way of handling errors. And please, when you write examples, write blog posts, write documentation, think about errors. Even if you say error handling omitted, but here's a hint in the right direction. Try to think about that at the time rather than not mentioning it at all. So, thank you.